Good morning. Today we are going to discuss a program that accepts input from user and checks whether a given number is prime or not. So in this program we will first write a program for the purpose, and then we will evaluate the performance of the program as well, and accordingly we will modify the code so that the program should be efficient and should take less time in execution. Okay, so let's start with the program. Now we have already declared two header files, and now start with main function. So we are inside the main body. Now declare a variable, say num, which will store the number entered by the user, and next one is your loop variable I, and you need a variable, say count, that counts the number of times loop is executed so that we can evaluate the performance of the. Declare one more variable called, say, flag. This variable initialized with 0, and we will change its value to 1 when the number is divisible by any other number that is other than 1 and itself. As you already aware that a prime number is a number which can be divisible by 1 and itself. So we will change the value of flag to 1 if the number is divisible by some other number. Okay, so this, if it is flag is 1, it means that it's not a prime number, and if it is 0, so it is a prime number. So let's start with displaying the message to the user. Enter number, terminate the statement. Now use scanf. Within scanf, write %d and then ampersand, name of the variable, that is num. Okay, so this message will be displayed on compilation and executing the program, and the number entered by the user will be stored in num. Okay, let's start with the loop. We are using for loop here, and initialize I with 2. Why we are initializing it with 2? Because we are already aware that every number will be divisible by 1, so we need not to check, and we will start with 2. Okay, so next is the condition section. Condition section is I is less than equal to num. Instead of that, this one right now we are taking I is less than num. That is, so here we are taking I plus plus. It will increment the variable by 1, and this loop will divide the number from 2 and to up to number minus 1. So first write the code, then we will discuss how it's working. So within if write condition num mod 2 is double, sorry, not 2, num mod I is double equal to 0. In this case, what you can do, you can simply change the value of flag is equal to 1. And one more thing that we can do is we can simply increment the count variable here. So we can write it here only, and initialize count with 0 also. This is just to keep track of how many times loop is being executed. So now come outside the loop and write if flag is equal to 0, then printf %t is a prime number. So you can write the number here, num. It will display something like 10 is a prime, 7 is prime number, like that. And we will else simply write the same statement. And here you will write is not a prime number. So if flag is 0, then it will display it's a prime number. If it is non-zero, it is having some other value, so it will be it won't be a prime number. Here what you can do, you can also display masses the value of count. So you can write %t loop, you can write /n, and loop is executed this much of times. How much? So you can write count. Okay, now just try to get ch. Now let's try run the program. Here we have taken num. This will store the number, and I is used to run the loop. Count is used to check how many times loop is being executed, and flag is to keep track of if number is divisible by some other number other than 1 and number itself. So here we are taking input of the number, and here the loop, we are starting loop with I is equal to 2. What will happen? It will start dividing number from 2, and we will go up to num minus 1. That is, we will not divide the number by either 1 or the number itself. So if the number is divisible by any other number, it means it is not a prime number. Here count plus plus is incremented, so it will finally display you how many times loop is executed, and is used here to divide the number and check if it is divisible by the number, by any other number. Say you have taken 10, so 10 will be divided by first by 2, and it will be checked. So it is completely divisible, so it will be equal to 0, so it will change the value of flag to 1. And then again it will continue the loop, and it will now check the number with 3, 4, 5, 6, 7, 8, and up to 9 it will perform the similar operation. So let's compile. Now here you are comparing if flag is equal to 0. So in case the number is 10, here already you have seen flag is 1. So it is not going to be a prime number, so it will just go to the else, and it will display 10 is not a prime number. And count will display how many times loop is executed. So just first save the program and compile it, then we will check the output. So execute the program now. Here it is asking you to enter a number, say it's 10. 10 is not a prime number. Loop is executed 8 times. So enter another number. This one is say let's 9. It's again not a prime number. Let's try to enter some prime number like say 13. Let's enter 13. 13 is a prime number. Fetching some other number. Say if you're taking say 40, how many times loop is executed? You can see 38 times loop is executed. So program is giving us correct output. 40 is not a prime number. But what is the key issue here? We are executing the loop so many times. So let's now modify the program to make it efficient. So first change you can do is you can reduce the loop execution by simply writing divided by 2 and this is equal to 2. As you must be aware, say if you are taking 10, it can be divided maximum by 5. It cannot be divided by 6, 7, 8, 9, 10, 11. So it is useless to check whether a number is divided by and divided by 2 plus 1, that is 6, 7, 8, 9, 10. So what you need to do is just you can write I is less than equal to num divided by so 10 will be divided by 2, so you will get 5. So it will check the from starting from 2 to 5. So we are writing equal to. So this will just reduce the execution number of times it is executed and time requirement. Say again you can enter 40 and now check it. It's 19. So we have reduced compilation of program by half time, but still we can further modify and reduce the execution time. So what you can do once you have detected that is this number is divisible by this, so say 40 is divisible by 2, so you need not to check it any further, that is 3, 4, 5, 6, unnecessary we are checking it again and again and again. So what you can do, you can put a break here. It will immediately exit you from the take you outside the. So now check what is happening here. Again I am entering 40. How many times loop is executed? It's executed only once. So enter any other value, just check it whether it's working or not. Say 19 is a prime number and loop is executed 8 times. Because it is a prime number, it will check all the numbers right from 2 to 9. Okay, in case of prime number it will be executed half time, and in case even numbers it will be executed only once. So I hope this will help you to write an effective program. That's all for now. Thank you.